Welcome to Ask and Learn.
In this question, we are trying to produce C2H4O, which is our main product, and for that we can have two different methods. The first one is this chlorohydrin route, while the second one is this catalytic route. So now, first of all, in the first subpart, we need to find out what are the atom economies of both of these methods, right? Now, atom economy is uh, obtained by the formula that says molecular weight of utilized atoms divided by the molecular weight of all the atoms, and this ratio is then multiplied by 100. So basically, when we use all the reactants, we need to identify what atoms are actually being utilized for the formation of our desired product and what are going to be wasted, right? Now, since we are talking about the formation of C2H4O, so basically, for the first reaction, or we can say for the chlorohydrin route, we can say that only C2H4 and one oxygen atom would be needed, right? So these are the atoms that are actually utilized, while all the other atoms are basically wasted, right? So we can say that in the formula of atom economy, we can write as in the numerator we can write that molecular weight of this C2H4 unit plus the atomic weight of one oxygen atom is what we require, and this is going to be divided by the molecular weight of all the atoms. So basically we can write that the molecular weight of C2H4 plus molecular weight of Cl2 and plus molecular weight of calcium hydroxide multiplied by 100. So putting up the values, we can get we can easily say that the numerator becomes 28 for this C2H4 and plus 16 because the atomic mass of oxygen is 16 only. Now again, writing 28 in place of the molecular mass of C2H4 plus 71 in place of molecular mass for Cl2 and plus 74 as the molecular weight of calcium hydroxide, and this is multiplied by 100. So solving this, we can get 25.43%. So basically atom economy for this first route or chlorohydrin route is obtained as 25.43%. Now for the second route, or we can say catalytic route, this atom economy would again be obtained as the molecular weight of C2H4 plus the atomic weight of oxygen atom, because these are the two that are being utilized, or we can say that these are the atoms that we need to form our desired product. Now the molecular weight of all the atoms that are involved would include the molecular weight of C2H4 and the molecular weight of half O2 molecule. Now half O2 essentially means one full oxygen atom. So this again is multiplied by 100, and since both numerator and denominator are 1, or we can say are same, so we can say that these would be cancelled out and the atom economy for the catalytic route would be obtained as 100%. Now in the second subpart of this question, we are expected to find out what is the percentage yield of C2H4O product in the catalytic route. So the percentage yield is given as the ratio of actual yield to theoretical yield, and this ratio is then multiplied by 100. So this is the formula we use for percentage yield. Let us write it as equation number 1, or we can say formula number 1. So now what is given to us is the chemical equation representing the catalytic route, and it is C2H4 plus half O2, and this results into the formation of our product C2H4O. So basically it has been given that we are using 867 grams of this C2H4 to synthesize 762 grams of our product C2H4O. Now we need to find out what is the percentage yield. So basically the actual yield for our product is 762 grams, and theoretical yield we need to find out. So now for theoretical yield, we first of all find out the number of moles of C2H4. Now this is going to be equal to 867 gram. This is the weight of C2H4 that we are having, divided by the molecular weight, and it is 28 grams per mole. So basically the number of moles of C2H4 would be obtained as 30.96, or we can say approximately 31 moles of C2H4. Now, from the stoichiometry of this reaction, we can say that the number of moles of C2H4 that are reacting would be equal to the number of moles of C2H4O that are formed. So basically, number of moles of C2H4O product are also equal to 31 moles. Now, the mass of C2H4O that would be produced theoretically would be equal to 30.96, or we can say 31 moles multiplied by its molar mass, that is 44 grams per mole. So now this product becomes 1362.43 grams, and 43 can also be neglected, so we can round it off to 1362 grams, right? So this is the theoretical yield. Now the percentage yield formula is applied, and we can say that actual yield, which is 762 grams, is divided by the theoretical yield 1362 grams, and this is then multiplied by 100 to get the final percentage, and this is obtained as 56%. So this is the percentage yield of the product in given conditions.